In this chapter 4.6, we're going to solve polynomial and rational inequalities. First, we'll start with polynomial inequalities. The steps to solve these are: 1, to find an equivalent inequality where p of x is equal to 0. Solve it. That's step 2. And then in step 3, use the solutions to divide the x-axis into intervals. We will call these my critical points. And we're going to test a value within each interval to determine if the polynomial sign, to determine what the sign is on the interval. Got a little typo there. So that's number 4, and this is 5. The fourth step is to determine which intervals makes the inequality true. And then the last step, 5, is if an imaginary solution exists, we just ignore it since the final answer can't be written with imaginary numbers. So to solve for number 1, we have 4x to the third minus 7x squared is less than or equal to 15x. Using the steps above, we're going to set everything equal to 0. So we'll get all the terms on the left. So we have 4x to the third minus 7x squared minus 15x is less than or equal to 0. And then we're going to solve a related polynomial where we have it equal to 0. So to solve this, we can factor out an x. And we keep going. Using the group method, let's multiply a times c. So 4 times negative 15 is equal to negative 60. And we're looking for factors of negative 60 that add up to negative 7x. Or I'll just say whose sum is negative 7x. So the best way I think of to do this is to make a factor tree with anything that you know. Go into negative 60. So 6 times 10, I'm just going to ignore the sign for right now. 10 is 2 times 5. 6 is 2 times 3. And so I want a negative 7. And I see I have all prime numbers now. So I can see a 5 times 3 is 15, and then 4. 15 and 4 don't make 7. I can try a 6 and 10, or maybe try a 5 with these numbers. So 2 times 3 times 2 is 12. I think we've got it. So 12 and 5, if we combine those, we can add them up. We can get a negative 7 if the 12 is negative and the 5 is positive. So now that we have our factors, we can use the group method, and we have 4x squared minus 12x plus 5x minus 15 equals 0. Combining the first two terms, I'm going to factor out a 4x. And what's left is x minus 3. So that's the first two terms. The second two terms, we can factor out a 5x or just a 5, and we're left with x minus 3. We can factor out the x minus 3 from both terms, and we're left with 4x plus 5. And now we have a completely factored equation. So the this equation can now be rewritten in terms of linear factors. X times x minus 3 times 4x plus 5 equals 0. So the solutions to this equation are 0, 3, and to find the third one, 4x plus 5 equals 0, and solve for x, and we have negative 5/4. So those are my three critical numbers. And negative 5/4 can be rewritten as a decimal, negative 1.25. That will help me plot that on the number line. Okay, so we're not done, because now what we have to do, all we did was solve the related equation when it's equal to 0. So now we have to solve the inequality. And the inequality has a less than or equal. So we'll go ahead and remember that when we draw the number line. I'm looking for intervals that make the inequality less than or equal. So on my number line, I'm going to put in the critical numbers here. So we've got in order. So I've got 0 in the middle, I've got my negative number on the left, the positive number on the right. And draw lines for each of these critical numbers. And so what I'm going to do is test some values inside each of these intervals and plug it into my polynomial. All right, so this is, I've just imported it down here again. And in fact, it's probably easier to put it in its factored form. So I'm going to go ahead and do that. The factored form is x times x minus 3 times 4x minus 5. So I decided to type it in to be a little more legible here. All right, so I'm going to pick some test points on each interval. So I'll put that in blue. So something smaller than negative 1.25 could be a negative 2. A number that's between a negative 1.25 and 0 could be negative 1. And a number between 0 and 3, I'm going to choose 1. And then a number that's greater than 3, I'll choose 4. And these are just random numbers that you can substitute into the equation, which I starred here. So P of negative 2 is, now I like the factored form, I think it's a little easier, so I'll put the negative 2 times negative 2 minus 3 times 4 times negative 2 minus 5, which is equal to negative 2 times negative 5 times negative 8 minus 5, which is negative 13. And a negative times a negative times a negative is a negative number. And I don't really care about the value of it. I just want to know whether it's positive or negative. So because it's negative, I'll go ahead and put that negative in that interval. We're going to go ahead and test negative 1 in the polynomial, and we have negative 1 times negative 1 minus 3 is a negative 4. I'll do a little mental math there. And 4 times negative 1 is negative 4. -4 minus 5 is -9. Because I have three negatives, I just paused my recording because I realized I copied that wrong. It's 4x plus 5. So the first point that I tested is still negative because that last one is a -3. It's still negative. So the whole thing is negative. For the test point of -1, I have a -1 times -4 times 1, which is a positive number. So I'll go ahead and put the positive there. For P of 1, I have 1 times 1 minus 3, which is a negative, times 1, let's see, 4 plus 5, that's positive. So we get a negative number. And then for 4, the test point 4, I've got a positive times a positive times a positive, which is a positive. Okay, again, I don't care about the actual outcome or solution. I just want to know if it's positive or negative. So we see that's positive. Now I want it to be this less than or greater than, so I went ahead and shaded the places where my test points were negative. So that means the whole interval there is negative. So I can now write the solution in interval notation. From what I shaded, I see I have a negative infinity to a -1.25. And looking at the original right here, this means it's closed. Union, and then we start at 0 and we go to 3. So we can solve a similar problem to the one in number 1, where instead of using less than or equal to, I'm going to flip the sign. So in example 2, here's my question. I want to solve 4x to the third minus 7x squared is greater than -15x. So what we need to do is group everything to the left side. We have 4x to the third minus 7x squared plus 15x is greater than 0. And this is the exact same polynomial that we had up here. And so we already know what the factors are. And that's what it is in factored form. So we have x times, let's see, x minus 3 times 4x plus 5 is greater than 0. And so our numbers, our critical numbers are 0, 3, and -5/4, which we know is -1.25. And now we take that number line, put in the critical numbers. We already tested the points, right? And we found the first one was negative, the second one was positive, the third one was negative, and the fourth one was positive. Just we can remember what we did there. Okay, negative, positive, negative, positive. And because we want the polynomial to be greater than, I'm going to shade the positive intervals. And we also know that this is an open interval. Therefore, we're going to have open intervals there. So the solution is from -1.25 to 0, union 3 to infinity.